So this is the half pass paper for week 1 for foundation. So half a pass paper, normally these papers are out of 80, but I've cut it down to just the odd numbers or just the even numbers. In this case, we've got the odd numbers, so it's just out of 36 this week. Makes it perfect for homework. So if you've been given this from homework, hopefully I can help you go through it and make sure that the answers make sense. So here we go. Question number 1, write 6,324 correct to the nearest thousand. So you've got your ones column, your tens column, your hundreds column, and your thousands column. So 6,324, we want to round to the nearest thousand, which means we check the next column over, which is the hundreds column. And since that number in the hundreds column is below 5, so remember 5 and above we round up, 4 and below we round down. So because it's less than 5, it's 4, 3, 2, 1 or 0, we're going to round down. So instead of going up to 7,000, if we are rounding up, we're going to go down to 6,000. So always check the next number over. If you're rounding down, the 6 is going to stay the same. If you're rounding up, it's going to go up 1. Question number 3, write 20% as a fraction. So percent means out of 100. So if you ever see 20%, you know that's going to be 20 out of 100. And we're not asked to simplify this here. So that would be absolutely fine for the marks. I am going to simplify it though. They are both in the 20 times table. So I'm going to divide the top by 20 and divide the bottom by 20, and that gives me 1/5. You could have also written 2/10. You could have written 10 over 50. All of these fractions are equivalent because we've divided the top and the bottom by the same. So as long as you've got a fraction equivalent to that, let's just put a fifth on the answer line here, but any of those would have got the mark. Question number 5, write down the first even multiple of 7. So multiples are numbers in that numbers times table. So the multiples of 7 are 7, 14, 21, 28, 35, 42, and so on. All the numbers that are in the 7 times table. We want the first even multiple, and even means it has to be in the 2 times table, so 2, 4, 6, 8, 10, 12 and so on. So we're looking for an even number, and that's going to be 14. 7 is odd, it's not in the 2 times table, but 14 is even, so that's the first even multiple of 7. Question number 7. Here is a probability scale. It shows the probability of each of the events A, B, C and D. So first thing that's worth saying is that 0 in probability means impossible. It absolutely cannot happen. It's impossible. And 1 means certain. Definitely going to happen. Absolutely 100% chance of that happening. Okay, and then a half in the middle, 50-50, so something like flipping a coin, something like that. So we've got A, we've got B, we've got C, we've got D. They are different things that are going to happen, and they've put them on the number line to tell us how likely they are to happen. Write down the letter of the event that is certain. So here we go. We know that if it's right up at the top there, if it's by 1, that is certain, definitely going to happen. Part B, write down the letter of the event that is unlikely. So unlikely is going to be A and B. They're down here at the bottom, but A we know is absolutely impossible, never ever going to happen. So it's B that's going to be unlikely. It could still happen, but it's not very likely to happen. So those are the ones that were right down the bottom. B was unlikely there. C, I would say that's likely to happen. It's more than half. That's probably how you'd describe that one, but and they didn't ask us anything about that, so that's fine. There are 12 counters in a bag. 3 of the counters are red, 1 of the counters is blue, 2 of the counters are yellow, and the rest are green. Caitlin takes at random a counter from the bag. Show that the probability the counter is yellow or green is 2/3. Okay, so we've got 1, 2, 3 that are red, red, and red. We've got 1 that's blue, and then 2 that are yellow. So let's just draw those. I often find it easier to draw it. And then the rest of them are green. So the rest is just going to be how many more we've got to get up to the 12 counters we've got all together. So far, we've got 6 counters. So there must be 6 more that are all green. So these ones are our green ones. There we go. Show that the probability that this counter is yellow or green is 2/3. Well, the yellow and green ones are these ones. We've got 6 that are green and we've got 2 that are yellow. So 2 add 6 is 8. There are 8 counters altogether that are yellow or green. Out of how many counters have we got altogether? 12. Now that isn't what they've given us, but we can simplify our fraction and that should be the same. So 8 and 12 are both in the 4 times table. And if you've got a number that you can divide them both by, like in this case they've got a common factor of 4, we want to divide by that to simplify the fraction. So dividing the top by 4 and dividing the bottom by 4 gives me 2/3. And there we go. Now we've got the same as them and we've shown that that is the probability. Question number 9. The centre of this circle is marked with a cross. Write down the mathematical name of the straight line shown in the circle. So a few things that we need to know with circles. This line, if it goes from the middle of the circle to the edge, is called the radius. So the radius of a circle is the distance from the middle of a circle to the edge. And it could be anywhere. It could be up here, could be going over here, could be going down here. All of those distances would be the same. That is the radius of the circle. Now, if you had a circle and you had the line going all the way across, going through the centre, that would be the diameter, and people often confuse those two. So diameter goes all the way across, radius just goes from the middle to the edge. Part B, write down the mathematical name of the straight line that is touching the circle. So this is another one that you just need to know the name of it. If we have a line that just skims the edge of the circle, that is called a tangent. And there are a few more circle parts that you should probably know. So if you had a pizza slice shape like this, that is called a sector. If you have a line going across the edge of the circle like this, not going through the middle, but going inside, that's called a chord. And then the area that is made between the chord and the edge of the circle, that's called a segment. So they're all really good things to learn and make sure that you know. But in this case, we had radius for the top one and we had tangent for this one. Okay, question number 11. Write down an example to show that each of the following 2 statements is not correct. The factors of an even number are always even. So we want to find an example that makes this not true. So they are saying the factors of an even number are always even. So let's take 10, for example. 10 is an even number. What are the factors of 10? So factors are numbers that fit into that number an exact number of times. So we've got 1 and 10, we've got 2 and 5. All of those numbers fit into 10 an exact number of times. They are factors of 10. 10 is an even number, but not all of these numbers are even. 10 is even and 2 is even, but 5 is odd. So there we go. We found an example where the factors of an even number, the factors of 10, aren't always even. So we found an example where it does not work. So I'm going to say 5 is odd and is a factor of 10. And then what about part B? It says all of the digits in an odd number are odd. So let's take the number 37. 37 is an odd number because it ends in a 1, a 3, a 5, a 7 or a 9. So remember, if it ends in a 2, 4, 6, 8 or 0, then it's even. But if it ends in a 1, 3, 5, 7 or 9, it's going to be odd. How can we make there be an even number in this? Well, this number, it doesn't make a difference what this is. It's still going to be odd no matter what this number is, or no matter what numbers come in front. So if I took the number 47, that's still odd, but now it has an even digit. So I'm going to say 47, and then we don't even need to write an explanation. That's all good. 47 is an odd number, but it does have an even digit. Okay, question 13. A piece of wire is 240 centimetres long. Peter cuts 2 45 centimetre lengths off of the wire. He then cuts the rest of the wire into as many 40 centimetre lengths as possible. Work out how many 40 centimetre lengths of wire Peter cuts. So he's got a bit of wire that is 240 centimetres long. First, he's going to chop off a bit that is 45 and another bit that's 45. And then whatever's left, this bit, he's going to chop that into as many 40 centimetres as possible. So what we need to know is how long is this bit and how many 40 centimetres fit into it. So far, we've chopped off 45, add 45, which is 90. So let's do 240, the total length, take away 90. So 0 take away 0 is 0. 4 take away 9. Now, don't be tempted to put 5 there. If there's more on the floor, you need to borrow from next door. So if you're subtracting and that bottom number is bigger, you need to go ahead and borrow 1 from the next column over. So I've changed that to a 1 from a 2, and I'm going to borrow 1 and make it 14. Now, 14 take away 9 is 5. And then I've just got the 1 here, so 1 take away 0 is 1. So we've got 150 centimetres left. So that's the length of that bit. How many 40s go into that? Well, I can do 40. Another 40 would be 80. Another 40 would be 120. And another 40 would be 160. And that's going to be too big, so we can't do that. But we can do that third. So 40, 80, 120. There we go. So it's going to be 3 more. Work out how many 40 centimetre lengths of wire Peter cuts. So the answer is 3. It's 3 whole 40 centimetres that we can fit into that bit that is left. Well done if you got that. Question number 15. Work out 15% of 160 grams. So helpful percentages to be able to work out. If you have 160 grams, and again I'm drawing, don't be scared to draw things in the exam. If you want 10%, 10% fits in 10 times. So if you've got 100% of a number and you want to get to 10%, you're just going to divide it. I've kind of committed to drawing all of these out now. Oh, not very evenly, but hopefully you get the idea. You fit 10% in 10 times. So if you just want to know what 10% is worth, we're going to take the 160 and we're going to divide it by 10. And that gives us 16. When we divide by 10, we move all the numbers one place value over, so that's going to be 16. So 10% is 16. And then the beauty of percentages is if you want 5%, well, that's okay. We know what 10% is. So to get 5%, that's just half as much. So I'm going to divide both sides by 2. And as long as you do the same to both sides, that's going to stay equivalent. So if 10% is 16, then 5% will be 8. And hopefully now you can see that if I want 15%, then I can just add those two together. So 16 add 8 is 24, because 10 add 5 makes 15%. So 15% is worth 24 grams. And you want to make sure that you put grams on the answer line, but they already had it here for us, so we were okay with that. Question number 17. There are some chocolates in a box. A quarter of the chocolates contain nuts. The rest of the chocolates do not contain nuts. Write down the ratio of the number of chocolates that contain nuts to the number of chocolates that do not contain nuts. Give your answer in the form 1 to n. So lots and lots of different ways you can do this, okay? If a quarter of the chocolates contain nuts, I'm going to draw this again. So if I've got a quarter that contain nuts, that looks like that. 1/4 is 1 out of 4. Then the rest do not contain nuts. And hopefully that makes sense if I say that that would be 3/4 have no nuts. So if 1/4 has nuts, then 3/4, the rest, would not have nuts. Write down the ratio of the number of chocolates that contain nuts. So that needs to go on the left-hand side of the ratio. So that's 1/4. And then as a ratio to the number that do not contain nuts, and that's 3/4. So there we go. But we can't leave it like that. They want it in the form 1 to n. So I need to make this left-hand side a 1. And with ratios, as long as you do the same to both sides, you're going to keep it equivalent. So how do I get from 1/4 to 1? I actually just need to times by 4. And the same on this side. If I times by 4, I'm going to just get 3. And hopefully that makes sense. Looking at my picture as well, it was one section that had nuts and 3 sections that had no nuts. So the ratio of nuts to no nuts is 1 to 3. So there we go. Let's pop that on the answer line. And our answer is in the form 1 to n, where n is 3. Question number 19. 2 and a 7th, we're going to multiply the big number here by the denominator. So 2 times 7 is 14, and then add on the extra 1. So 2 times 7 is 14, add the 1 is 15 sevenths. So that's the first thing we're going to do. And then same here, multiplying 1 times 4 is 4, add the extra 1 is 5. So we've got 5 quarters coming from that fraction. So 15/7 add 5 quarters. And we now want to make these denominators, the bottom numbers here, we want to make these numbers the same. So we're looking for a number that's in the 7 times table and the 4 times table, and that's going to be 28. So we're going to make both these fractions out of 28, and to keep them equivalent, whatever you multiply the bottom number by, you also need to multiply the top number by. So we've multiplied that by 4 to make it out of 28, so we also need to multiply the top number, the numerator, by 4 as well, and that's going to be 60. 15 times 4 is 60. With the second fraction, I've multiplied the denominator by 7 to make it out of 28, so I also need to multiply the numerator by 7, and that's 35. Now we can go ahead and add those fractions because the denominators are the same. So we keep it out of 28, don't ever add the bottoms, they stay out of 28. And I've got 60 add 35, so that is 95 out of 28. Now it hasn't said to put it back as a mixed number, so that's absolutely fine, we can leave that answer there. If it did say to give your answer as a mixed number, we would need to say, okay, how many 28s go into 95? So I've got 28, add another 28 is 56, add another 28 is going to be 84. And I wouldn't fit another one in. So I've got 1, 2, 3 times 28 goes into 95. So that would be 3 wholes. And then from 84 up to 95, that's 11 extra left over. So I've got 11 28ths left over. Now that question did not say you must give your answer as a mixed number. So this would be absolutely fine for full marks, and this would be absolutely fine for full marks, and that would be 2 marks for that question. Part B, work out 1 1/5 divided by 3 quarters. Now again, if you see any mixed numbers, we're going to make them top heavy. So let's do that first, and we're doing the big number multiplied by the bottom number, add on the top. So 1 times 5 is 5, add the 1 is 6/5, and that's divided by 3 quarters. Don't need to do anything to the 3 quarters because it's already a fraction, not a mixed number. And then we're going to keep, change, flip. So when we divide fractions, it's the same as multiplying by its reciprocal. And a reciprocal is a fancy word for when you're inverting that fraction and putting the denominator on the numerator and the numerator on the denominator. So there we go. We've got the same question there. Dividing by 3 quarters is the same as timesing by 4/3. And once we're timesing, this is lovely. We don't need to make the denominators the same when you're timesing or dividing. We're just going to do the top times the top and the bottom times the bottom. So that's going to be 24 out of 15. Now this one does say give your answer as a mixed number in its simplest form. So I need to think how many 15s fit into 24, and that goes in 1 whole time. 2 lots would be 30, and that's too big. And how much have I got left over? So to go from 15 up to 24, that's an extra 9 out of 15. Now that wouldn't get us full marks, because remember it also says in its simplest form. So I'm looking at this fraction part and thinking, are 9 and 15 both in the same times table? And they are, they're both in the 3 times table. So I'm going to divide that by 3 on the numerator and the denominator to simplify that fraction, and that's going to be 1 and 3/5. So that would be your final answer for 2 marks. Question number 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. Renee puts all the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. Renee sells all the bags of sweets. Work out her percentage profit. Firstly, she pays £10 for all the sweets and she's bought 5 kilograms. Now she's going to put them into bags, and the bags are 250 grams each. So the first step here would be to work out how many little bags she can do. So the first thing to note is that 5 kilograms is 5,000 grams. We're working in kilograms, but we're also working in grams. So let's get them the same. 5 kilograms is 5,000 grams. Killer anything. If I said I've got 5k in my bank, a lot of you would think, okay, that's £5,000. So kilograms is 1,000 grams. So 5 kilograms is 5,000 grams. Perfect. And now we need to say, okay, well, how many 250s can I split that into? Okay, so I need to do 5,000 divided by 250. Now, when you've got a tricky division, it's quite big numbers, I quite like to write it as a fraction and then just simplify that fraction. So 5,000 divided by 250, let's simplify that fraction. Let's divide them both by 10. and that gives 500 divided by 25, and that's equivalent, that's the same question. And now I'm going to divide them both by 5, because I'm noticing that both those numbers are in the 5 times table, so that would be 100 over 5, and now it's a little bit easier for us to do. 100 divided by 5 is 20. The other way to think about it is 250, 500, 750, 1,000, so every 4 makes 1,000, and because I've got 5,000 I can do 4 times 5, and that's 20 as well. So a couple of different ways of doing it, and then we need to times that by 65p, because that's how much she's going to get for each bag. So 20 times 65, and let's do this by the lattice method just because I love it. It's a great method to do. So 65 times 20, split every box diagonally. 5 times 2 is 10, so that goes there. 5 times 0 is 0, so we just put 0, 0 down there. 6 times 2 is 12, so that just goes there. And 6 times 0 is 0, so that goes there. You then just add down each diagonal section. So just 0 in that first section. 0 add 0 is 0. 2 add 1 is 3. And then that last section is just a 1. And because it is 65p, it's got a decimal point here, because I want to get my answer in pounds, and 20 has a decimal point here. You go down with one decimal point and across with the other, and wherever they meet, that's where you go down the diagonal, and that tells you where to put the decimal point. So this is £13. So what's her profit? Well, she spent £10 in the first place. So £3 profit. And when we're calculating profit, we do the profit over the original times by 100. So profit is the extra money you've made over the original times by 100. So that's £3 out of £10, which is what I spent out originally, or what Renee spent out originally, times by 100. Now 3/10 is 0.3 times by 100 is 30% profit. And that makes sense in this case. £10, £3 out of £10, we know that's going to be 30%. So well done if you got that. Perfect. 30% profit. Okay, question number 5. Here is a solid square-based pyramid, VABCD. The base of the pyramid is a square of side 6. The height of the pyramid is 4, so that's going straight up. M is the midpoint of BC, and VM equals 5. Draw an accurate front elevation of the pyramid from the direction of the arrow. So they're asking you, if we're looking at it from this direction, what would it look like in 2D? What would it look like straight on? Now, you'd only see this face. You'd only see this triangle here. If you were looking at it dead on from that direction, you wouldn't see the side. You'd just see it dead on. How tall would it be? So when you're looking at it, it would be 6 wide, we can see that from the base there. But the height, it's a little bit confusing because they've said it's 5 centimetres, but they've also said it's 4 centimetres tall. Now 5 centimetres is the distance diagonally across that face. But looking at it dead on, the height going straight up is just 4. So when I'm drawing this, I need to make sure that I'm drawing a triangle that is 6 wide and going up by 4. Yes, this sloping distance is 5, but that's not very helpful for this. We just want to make sure we draw it 4 up. So I'm going to get my ruler here and I'm going to draw it 6 wide. So 1, 2, 3, 4, 5, 6. They've told me it's centimetre grid, so I don't need to use my ruler. And we're going up by 4. Now I'm going in the middle here, 1, 2, 3, 4. So I know I need to go up to this point and then just make it symmetrical like that. There we go, and that's the front elevation of the pyramid. Work out the total surface area. So for surface area, you want to think about the area of every single face added together. So if I just unfold this pyramid, it would look a little bit like this. I know that the square is 6 wide and 6 tall, and I know that the triangles, they have a height of 5, because when you lay them flat, it's going to be that diagonal length. That's the distance from the bottom of the triangle to the top of the triangle. 4 is just how tall it ends up being when you slope the triangles. So 5 is the height of those triangles when you lay them flat. So they are going to be 6 wide and 5 tall. So the square is 6 times 6, which is 36 centimetres squared. And then each of the triangles is base times height divided by 2 for the area of a triangle. So 6 times 5 divided by 2. So 6 times 5 is 30, and 30 divided by 2 is 15. And I've got 4 of those triangles, so 15 for this one, 15 for this one, 15 for this one, and 15 for this one. 15 times 4 is 60. So I've also got 60 centimetres squared for the triangles. Adding that together, our total surface area, the area of all the faces added together, is 96 centimetres squared, because we're working in centimetres. Note that there was no units there, so you're going to get a mark for putting the units in. On the grid below, draw the graph of y equals 1 minus 4x for values of x from minus 3 to 3. So when we are drawing a straight line or a curve or anything on a graph, I'm going to do a table of values. Now, a table of values looks a little bit like this. We're going to put an x on the top and a y on the bottom, alphabetical order, if that helps you remember. And it says we want to do values of x from minus 3 to 3. So that means I'm going to do the x numbers going from minus 3 as the first number, and then minus 2, minus 1, 0, 1, 2, 3. Just like the numbers on the number line here. They've gone up to 4 and down to minus 4, but we just need to do minus 3 to 3 from the question. Okay, and then this part is the instruction. It's saying to get y, so to get the number that needs to go down here underneath, you need to do 1 take away 4 lots of the x. So let's start with 0. That's always going to be the easiest one to do. So for this one, for 0, we need to do 1 take away 4 lots of 0. So 1 take away 4 lots of 0. Well, 4 lots of 0 is just 0. So 1 take away 0 means that's just going to be 1. What about 1? Let's try the next one. We want to do 1 take away 4 lots of 1. Now 4 lots of 1 is 4. So we are doing 1 take away 4. And 1 take away 4 is going to take us, think about your number line, down to minus 3. So that one's going to be minus 3 there. Let's try 2. So that's going to be 1 take away 4 lots of 2. And 4 lots of 2 is 8. So 1 take away 8 is minus 7. Let's try 3. We're going to do 1 take away 4 lots of 3. So we're just changing the x to be whatever number we're looking at. So 4 lots of 3 is 12. 1 take away 12 is minus 11. And hopefully you can see maybe that there's a pattern forming here, that this is going down in 4s each time. So from 1 to minus 3 to minus 7 to minus 11. So if you want to go the other way, you can cheat and go up in 4s. You can kind of put that in and fill in the pattern here. We're going to be going down in 4s because it's minus 4x. But let's just do it with the numbers. Let's carry on doing it in the same way. So I'm now going to do 1 take away 4 lots of minus 1. Now here is where it gets a little bit trickier, because 4 lots of minus 1 is minus 4. So you're doing 1 take away minus 4. And that minus, if you're taking away a minus, is going to become a plus. So that is actually going to be 5. And that makes sense. You can do the same with the minus 2, and that is 1 minus 8, so that's going to be 9, and then the same with the minus 3, and that's going to be 13. What you've then got is lots of coordinates that can be plotted on your graph. So first I'm going to plot minus 3, 13, so I'm going across to minus 3 and up to 13, so that's going to go there. Then I'm going to plot minus 2, 9, so minus 2, 9 goes here. Then I'm going to plot minus 1, 5, which is here. Then I'm going to plot 0, 1, which is here. Then I'm going to plot 1 minus 3, which goes there. And hopefully you can see this is forming a nice straight line. And then 2 minus 7. 2 minus 7, which is there. And the last one, so 3 minus 11. Like that. And then because we're drawing a line, we're going to join them all up with a ruler. See how I do on the iPad. I always find this a bit difficult. And you want to go through, see, I've done that badly, let's try again. All of those points and go to the edge of the graph. And there we go. So that is 3 marks for a fully correct graph for that question. And that's the end of the half-past paper. I hope you enjoyed it. Join me next week for the next one.